Alright guys, hey, what's going on? Bear with me, this is the first video that I'm making, so it's probably going to be a little bit rough, but thank you guys for being patient online. This isn't the ideal way for you to learn this subject, but we're going to do our best here. Okay, so the topic that we have been working on is called mole calculations. We've done quite a bit with this so far, guys. You are good at this, alright? Relax, we're going to get through it together, so just stay calm and I will do my best to explain it here if that works for you. Alright, so what we learned before we left school. First thing we worked on was dimensional analysis. This was just a strategy that we learned so that we can tackle problems that have lots of different numbers and lots of different units in them. We started off by working with pretty basic problems, the pizza party problem, the wing problem, all those. Okay. That was our strategy for tackling some of the confusing stuff that we're hitting now in this class. So this is the chart thing, right? We learned how to find conversion factors. There's tiny little equations that set one unit equal to another. All right? I will put up a separate video on a recap on that material if you guys need it. Our next topic that we learned was Avogadro's number. Okay, Avogadro's number is one of these conversion factors that we used in dimensional analysis. Right? It's used for really, really large amounts. Specifically, we use it to talk about how many particles of a formula there are. Right? So this is Avogadro's number right here. 1 mole of anything equals 6.02 times 10 to the 23rd particles of that thing. Right? We had a TED Ed video that we watched on that. That is on Google Classroom if you need it as well. Next topic we learned was molar mass. Molar mass is also another conversion factor. This time it's for a specific formula. Okay, so we use the periodic table to find that. That is where we added up all of the different average atomic masses for the elements in our formula, put them all together, and we had our molar mass. So there's a separate video also that should be available soon if you're having trouble with molar mass. Right? So when we learned all of this, I gave you guys this flow chart. It looked kind of just like this. Okay? So this y up here, any amount of y represents a formula. Okay? So for this formula, we can talk about in any of these units, particles, moles, grams. It's still the same formula, still the same amount of material we're working with. On this flowchart, you find what unit you start with. So say I start with grams for this formula. I can convert it to moles or particles, and to do that, I would use these conversion factors that we've already learned how to find. To get from grams to moles, you would need a molar mass. Look at the periodic table, add all our numbers up, gives you this conversion factor, which we get to use in our dimensional analysis chart. Okay, so our new topic, the one that we are learning, molar ratios, one that's really confusing for everybody. Okay, it's confusing because I think we're trying to use one conversion chart for that. For molar ratios, right, doesn't fall anywhere on this chart. It's talking about a different formula. So it's a way to get from one formula to another formula. I tried to put that graphic on our last worksheet to help you out, but it shows how we get from one formula to another using a molar ratio from a balanced chemical equation. So next video, I will show you guys how to find and use a molar ratio.